This video is for firefighters, explaining how to handle battery electric vehicles on fire, based on available battery fire research. It's also a video for vehicle manufacturers, since it seems like most manufacturers' recommendations is not in line with available research about how to put out battery electric vehicle fires. There is no scientific evidence that a battery electric vehicle fire needs large amounts of water to be put out, like most manufacturers say. A small amount of water on the right place could be enough, and that is something that I think the manufacturers have a responsibility to tell us. How do we get water inside their vehicle's battery casing? Because water inside the casing is what it takes to put out the battery fire. If you can't get water inside the casing, there is no need to cool the outside of the battery with large amounts of water, except for some cases. And all that and more is covered in this video.
Hi all, Per-Ola Malmqvist from Sweden here. I'm a fire protection engineer, former battalion chief and firefighter who have been working recently with trying to understand battery fires, more specifically electric vehicle battery fires. And this is what this video is about. This presentation is done together with Uppsala Fire and Rescue Brigade in Sweden. And our goal is to share the knowledge that we've found so far about this. The knowledge is a best before date. This is filmed in September 2020. And I think a lot of things is happening both in the firefighting field and in the battery field. So be aware that there is a best before date on this video. I will start with some research from 2012 here. It was a project in the European Union in the rescue team teaching program. They said that water is the extinguishing media that has the highest cooling potential compared to all other extinguishing media, which is true. About extinguishing battery fires, they said the material burning in the battery is mainly electrical components in form of plastic and electrolyte. The electrolyte is a hydrocarbon. And most extinguishing media works in principle, so there is no need for extinguishing media for metallic fires. And this is interesting because sometimes in previous research they have said that battery fires should be extinguished like metallic fires. And they also say that different manufacturers advise on how to extinguish a battery fire in different ways. Some say that you need water and some say you need sand. And that is, I think, because they believe battery fires should be extinguished like metal fires. However, what we are talking about here is a lithium-ion batteries. There is lithium metal batteries that are not chargeable, but lithium-ion that is rechargeable, they are not to compare with metallic fires. There was a project in 2012 in Sweden called the Rescue Chain, and they looked at what different manufacturers recommended as well, and they said large amounts of water or foam, and some even said that there could be carbon dioxide or dry powder, dry chemical extinguisher. They also made a look around the world to see how other countries, what they had found out. And they found an Australian, New Zealand document where they found some discrepancies. And the discrepancy was that some manufacturers said you should put it out with sand or graphite powder, and some said large amounts of water. And they even had some notes about not using small amounts of water because that could be dangerous. To me, all of this sounds like they are thinking metal fires, because small amounts of water on a metal fire will make hydrogen and oxygen, and in that way make the reaction even worse. So you need large amounts of water on a metal fire, or sand or graphite powders. So I think there is some kind of mix during this time, 2012 we're talking here, that makes people suggest that kind of measures. In 2013, NFPA with Exponent Incorporated made a very good report about where they have made full-scale tests on fires with firefighters, and they have some really good reading about how the firefighters experienced this putting out the fire. And what they did was they built a car where they could place a mock-up car where they could place the battery module in the back, and then they let the firefighters put out the fire without letting them know how to do, which was a genius thing, I think, because the firefighters figured it out after a while. They said, we can't get water on the fire, that is our main problem, even though in this case the battery is really like open to see, like it wouldn't be in a normal car. They had problems getting water where it would make good use. They also said that maybe a constant flow of water may cool the metal casing, and thereby reducing the chance of further cell thermal runaway. And I think this text here could be the reason that many car manufacturers today recommend cooling off the casing with lots of water. Note the may have in this sentence. They didn't say it worked. And I would say that what we know today, like 7 years after this, is that it doesn't work. Cooling the outside of the battery casing could be useful in some cases, but not for preventing thermal runaway. Yeah, they made several tests here. They made one test without putting it out at all. And it burned for like 35-45 minutes, and then it was over. Then they used the firefighters to put the battery fire out, and it lasted 35 to 45 minutes, and it didn't extinguish. And then they made a third attempt where they tried to put it out, and it burned for 35 to 45 minutes. And they used not a large amount of water, but what they saw was that when the water made use was when they found holes in the battery casing where they could get the water inside the battery casing. Then it took the fire out and reduced the thermal runaway. However, in this case, they didn't get a real good hole so they could fill the battery casing with water. But they saw the results when they got the water in there. In 2015, the Renault car manufacturer and the fire brigade made tests for the Renault electric vehicle. And those are very interesting tests as well, because they had the same problems that the NFPA tests had. They couldn't get water where it needed to be. But what they had a small aluminum lid on the battery that after a while that burnt away. And the firefighters realized that if we put water in that hole where the lid had been, they put the fire out. So the engineer at Renault, they made a new version of the battery pack where they had a plastic lid instead, and they placed it somewhere wise so it would be easy to get some water in there, and it worked. it worked very well. So with that lid burning a hole in, they could put the fire out. So if you look at a Renault today, we will look at a rescue sheet for a Renault Zoe. There is a fire water inlet. It's under the back seat, and when the back seat have burnt away, you will probably see flames coming up from that hole, and that's where they put the water. And I think that's the way to go for car manufacturers, to make it possible for the fire brigades to get water onto or into the battery casing. Also, we have some Chinese tests. Wuhan Institute of China Classification Society, Wuhan as we all know now, they did some testing with carbon dioxide, dry powder, and heptafluoropropane. The last one is a halon, which is not allowed in Europe or in the world, I think. And what they found out here is that dry fire extinguishing agents doesn't work well at all. What they did try was a foaming agent, which worked well to contain the fire and stop the thermal runaway within a battery casing. They also tested, or in the report they wrote about testing the F500 microcapsule technology, which is supposed to contain the hydrocarbons within extinguishing agents, and in that way cool and prevent the hydrocarbon from igniting. And they also made their own little dishwashing detergent kind of mixture. And that one and the F500 worked very well. When they got that into the battery casing, it was put out in 15 seconds. And if they used water and got it into the battery casing, it was like 45 seconds. In 2018, a Swedish report about batteries, lithium-ion batteries at sea, made some interesting conclusions as well. They tried fog sprinklers, and they concluded that if you don't get the wet agents into the battery casing, it will not end the thermal runaway. So there are several reports here that say if we don't get the water or the extinguishing agent into the casing, the thermal runaway will continue. Pure water proved to be effective in their tests. Also Class A foam, Class F foam worked well. CAFS, compressed air foam system, the wet version worked well, but dry foam didn't work as well. AVD worked well, and nitrogen did not work well. So everything that is wet worked well within the battery casing. Nitrogen and what was dry did not work at all. Okay, batteries. What's in the batteries? I tried to make it simple here. What we have inside the batteries is plastic, like the thing keeping the battery cells together. There is the electrolyte, which is a kind of a hydrocarbon, like kerosene, something like that, a flammable liquid. And we have chemically bonded oxygen. And besides that, there is a state of charge, energy stored within the battery. Together, those pieces, if in the beginning of a fire or in the beginning of a thermal runaway, there is some kind of event that happens that creates heat within the battery. It could be a short circuit within the battery, it could be a short circuit outside of the battery, and it could be some kind of mechanical event that affects the battery. It can also be heat from the outside that starts the thermal runaway. What happens first is that the kerosene, like hydrocarbon, evaporates and creates a pressure within the battery cell. When that pressure is high enough, the battery cell will break and you will have a liquid. Now, the liquid is reformed as a vapor. So you get a vapor cloud with flammable vapor that comes out of the battery. Sometimes that will ignite, and sometimes it will just be the flammable vapor that gets out and can ignite at a later stage. The next thing happening when we have that much heat is that the chemically bonded oxygen starts to release from where it was bonded. It is in oxides in the battery. And that is that the oxygen is delivered to the fire and creates even more heat from that thermal runaway. And in that way it will spread to more battery cells. If we look at this fire here, that is a large battery. To make it easy, let's say we have large battery cells and we have small battery cells. Those are large battery cells. You can see that we have a short circuit here on the battery, or an overcharge, I think it was in this case. And you can see that the vapor, the kerosene-like hydrocarbon, the pressure that it builds up breaks the battery casing, and we have the battery cell getting bigger and bigger, and finally bursting, and there is this flame. And that is the kerosene-like hydrocarbon that is burning. If we look at this video instead, here we have several small battery cells. This is a Tesla battery that is some DIY. They built a car with this, and they had an accident in their workshop. And it's a very good view of how the small battery cells work in a thermal runaway. If this would have been a normal vehicle like a Tesla, there are other protections in the floor, etc., that makes those flames we see here we wouldn't see coming through the floor in a Tesla. We would see flames coming out from the sides or something like that. But you can see here that we have a small cell explosion, a short fire, and compare that to the big battery cells where we had a longer battery fire. So what do we know about the fire when we have a battery fire? Well, we know that there are toxic smoke that have been discussed quite a bit. We know that there are gases that comes out of the battery cell that can burn, or it can be released like unburned gases. We know that we can't contain a fire within a battery module, a battery casing, by spraying water on the outside of the battery casing. And depending on how the battery is configured within the vehicle, we could have some use for cooling the battery casing, but that would be in that case to prevent that battery from catching fire. If we have a flame from somewhere else affecting that casing, then we need to cool it so we don't get starting a thermal runaway within that battery casing. We also know that preventing fire spread, to do that, it could be good to reduce the power from the fire, the rate of heat release. So by putting out a cabin fire or an engine compartment fire, we get less release of heat from the fire, and by that we can make it less likely that the fire will spread to something else. And we also know that the only way to put out a battery fire is to get some wet stuff into the battery module. And as I said in the beginning, this is September 2020. There is lots of things happening. So this is information with an expiration date. How long that expiration date is, I don't know. Okay, My background in the fire brigade is command and control. I was working a lot with that, and one of the main information we wanted to get into the communication center was how long will this take, so we know what to do in the region that we served. And when we're talking battery fires, I think we need to address them differently than normal vehicle fire. Like a normal vehicle fire is something you don't think about how long it will take. You know that it's over pretty fast and that the fire crew will be able to go to the next call pretty soon. But with battery electric vehicles, I think we need to rethink that. And for what I have seen in the reports I've read, I would say if you have a fire in the battery, like say an hour, and those are the small batteries. But if you calculate an hour for the fire, I think that's a good start. If you have a fire that is not in the battery, but in the cabin of the vehicle, if you have a fire there, that can affect the battery. So even if the fire is like a normal car fire, we need to make sure that we haven't get any heat released to the battery and that we have started a thermal runaway in the battery, because that can show like several minutes after the fire is put out. And a good way to do that would be like a thermal imager or something like that, and try to, if possible, look at that battery casing. What I'm going to talk about now is how to deal with different situations about battery electric vehicles. And I just, to make it easy here, I assume that the smoke is very toxic and you're supposed to be in the smoke as little as possible and as short time as possible. And this is of course harder inside and easier outside. So if we have a battery electric vehicle standing outside by itself, nothing close to it, and we have a fire in the engine bay or in the driver's area, the cabin. What we could do is to put that out as usual. After that, try to figure out where the battery is located and cool its outside. Because if it haven't started a thermal runaway yet, we have a good chance of preventing it from starting. I have seen some examples where it took about 20 minutes from an exterior fire until the thermal runaway started. And if we are dispatched to this scene, like when the car fire breaks out, we should have a good chance of stopping this from becoming a battery fire. Try to locate hotspots on the casing, on the battery casing. Cool them. If the hotspots reappear after they have been cooled, that's a sign that there is a thermal runaway going on. Maybe not as a runaway yet, but there is a thermal event going on that could result in a thermal runaway. It's important to figure out for how many hours you should watch this and look at it. I don't have that number because I don't think that knowledge is available yet. I hope it will be. And to finish up the job here, make sure that the car is placed somewhere where it's not in danger of any other cars or buildings. What we're talking about here in Sweden right now is to transport it somewhere where it can stand safe. For example, a fire brigade training field or something, and leave it there for a couple of days to see what happens. Let's say instead that we have a fire, same vehicle, but we have the fire in the battery instead. We still haven't got the fire inside the compartment, or we have started to get a small fire in the cabin. What we can do then is to prevent the fire from getting into the cabin. And that could be by filling it up with the medium expansion foam. We could use fire retardants to spray within it, or we could fill it with a little bit of water. Everything to keep the rate of heat release low from the total vehicle fire. And the other, if we do that, and then we let the fire burn to the end, the battery fire burn to the end, because cooling it on the outside, as we now know, doesn't work very well. So either let it burn until the battery casing is empty, or we can try to get water into the casing. And there are different ways of doing that. What we also can consider, we know that it's dangerous smoke, so we can either wash it down with like a fog nozzle and spread it out, disperse the fog, and maybe some of the bad things gets into the water. Or we could use a PPV fan, a 90 degrees angle to the smoke plume, and try to disperse it that way. And then again, after the fire, we need to put the car somewhere where it can burn. Even if we have had the battery burn out what we think is completely, what showed up in the NFPA test that we were talking about was that a battery casing that looked like it was completely burnt, one day, 24 hours or 22 hours after the tests, there was a fire from the battery casing, or in the battery casing. Okay, let's take the next step. Let's take a vehicle, battery electric vehicle. We have the fire within the cabin, and we have other vehicles close by. Make a normal car fire extinguishment in the cabin, and after that prevent the fire spread to the adjacent vehicles, and prevent reignition of the cabin. And after that, let the fire burn till it burned out. Same thing as the first vehicle. We can do some things with the smoke plume, and if we have the equipment to put the fire out, or we can see that there is a hole somewhere where we can put water in, okay, put the fire out. That's one option as well. And in this progress, because we have a lot of time now, when we know that we're just gonna protect the exposures from the burning vehicle, we can take a look at some rescue sheets and try to figure out how big is the battery in this vehicle? Where is it placed? Can I somehow, by looking at where the smoke comes out or where the fire comes out, can I assume how long time this operation will continue? And the same thing after this vehicle. I assume that the more there is left in the battery casing, the higher the risk of a reignition is. Okay, let's make this more difficult. If we have this fire inside, in a parking garage, the car is close to other vehicles, and we have the fire in the cabin. Same thing as before. If it's safe, put the fire within the cabin out, and then prevent fire spread to the adjacent vehicles. And here we need to think new, I think. Consider maybe a fire blanket of the large vehicle fire blankets. Put that on the vehicles beside the burning vehicle or over the burning vehicle. Put a water curtain, a nozzle on a monitor, on a tripod. Use those gel extinguishing agents. Use high expansion foam and foam the entire floor. Any method that would prevent firefighters from being in the smoke for a long time. Here in Sweden, we have now a kind of chosen time of 20 minutes in the smoke when it's battery fires. So that is what we think that is a decent amount of time where you still can go in and do something, and you're not a complete SCBA pack in there. You need to get out before that. Same thing as outside. Try to prevent reignition of the cabin And the reason for that is to keep the rate of heat release down. Because the higher heat release rate we have from the fire, the more we will affect the structure. There could be concrete above the car that will start to crack. So we will try to keep the fire down that we can affect. And the battery, we assume, or I assume in this case, that we can't affect. And therefore we will just spray water on the cars beside the burning car and have the firefighters go outside and maybe every 10 minutes take a look at how it looks and work at it that way. During this time you can wash the smoke, maybe. I don't have the figures for that, but there is an assumption here that by using fine water fog we could get some of the toxic things out of the smoke. But that is also no science behind that as I speak now. And finally get that vehicle away, but let the battery burn to the end. That's one option. There are mainly two problems after the fire. There are probably more, but I'll talk about two of them right now here. The one I have addressed earlier, that is that the battery can ignite again several days after the fire. So make sure to place the vehicle in a good place for this, so this could happen or can happen without any new fire spread or smoke contamination. The second thing is interesting. It was mentioned in the 2012 and 2010 reports. It was that the battery, when you put it out, it could be, if you have water within the battery casing, there could be an electrolysis. Yeah, I think that's the word. Electrolysis within the battery casing, which produce hydrogen and oxygen. And if that collects within the cabin of the car, then you could get an explosion from that. And they recommend that you should keep the side windows rolled down to keep ventilation of the car. I was talking a little bit about when it would be good to cool the outside of a battery pack. Here is an example of that. If we have a fire in one of the battery casings here, we could cool the other one with water to prevent a thermal runaway from starting there. And the only way to know that, if there are several or only one battery casing within the vehicle, is to look at the rescue sheets for the vehicle. This is vital information to know how the fire will end and what things you should do. I think we should start to consider car fires the same as industry fires, but in a smaller scale. But we needed information to make a very good operation, and that information is part of it on the rescue sheets. And here is another rescue sheet. It's the Renault Zoe that I was talking about, where you have this water inlet. I would never have guessed that if I didn't know it from reading here on the rescue sheet. I was talking a little bit about explosive gases. And I've mentioned both of them. I've mentioned the kerosene-like vaporized gas that could be like butane or propane gas. And I've mentioned the hydrogen and oxygen production from electrolysis. When we have a thermal runaway, sometimes the off-gassing of the gases doesn't ignite, and we get this kind of propane-like gas that can ignite and maybe explode at a later time. There have been a couple of cases where this have happened. We have the Arizona explosion in the battery energy storage systems. We have a Norwegian ferry where we've had an explosion a long time after the original fire. And there are also descriptions of this in different reports. And in some cases, there have been the use of dry powder or aerosols that seems to have some kind of influence on getting an explosion. I will show you a video of that a little bit later here. And the other thing is the hydrogen and oxygen production from the plus and the minus pole of the battery. And since there are many lines in the battery with plus and minus, there could be, probably be a lot of hydrogen and oxygen under the right circumstances. And this problem could be if we have had a car driving down in the water and we take it out again and we have maybe salt water in the battery. If you have salt in the water, that will make an even better electrolysis. And in both cases, to prevent explosion, if we have a battery fire and we can't get the vehicle out, or this could be for battery energy storage systems as well, ventilation is key. We need to ventilate the room where we have had the fire enough so that there can't be a buildup of explosive mixture of gases. Here is a video of hydrogen and oxygen generator. It's mainly plus and minus to two electrodes, the metal sheets, and it started to bubble hydrogen and oxygen from there. The other example is this here. It's a car battery that they have overcharged. We will see here that there is a lot of smoke produced. If this would have been indoors instead, you can see how the smoke builds up and it doesn't ignite, and then at a later stage we will see how it ignites. And this is when that ignition flame comes out, that could be the thing that ignites the explosive mixture of those gases. This is the Finnish rescue school that made some tests. They overcharged lithium-ion battery and they tried to put it out with an aerosol. And as you see, the cell has been venting for a while and suddenly it explodes. And it's a really tough explosion, I would say. So there is a lot to learn more about this, but one way to get this to not happen is to keep the room well ventilated, so there can't be this buildup of explosive mixtures. Leftover firefighting water. Depending on the tactics and methods, there could be a lot of toxic chemicals in the leftover water. And if we try to contain the fire and spray water on the surfaces we want to protect, we will probably drain less toxic things out of the burning vehicle than if we drench that vehicle with water. Also, to contain a fire, we probably need less water than we would do using the recommendations of large amounts of water and a long time. Since we know so much, we know that there are very dangerous chemicals in the electrolyte. We know that there are heavy metals that is very toxic, that is released both in soot from the fire and in the water from when we try to extinguish the fires. So that is also something that we need to add to our firefighting effort, the leftover water. That it's not okay to just let it out in the nature. We should start to make plans for taking care of that water and make it as little as possible. If we use less water, we also get less to take care of, which makes it easier to take care of it. Parking garage fires are complicated fires to deal with. Underground parking garage fires even more so, with all the different fuels we have in the vehicles. I think we need to pre-plan them, and I've been thinking a little bit about how to do that, what would be useful. In Sweden we have the 20-minute mark. We don't want firefighters more than 20 minutes in the electric vehicle fire smoke. And that means that the way you maybe normally enter a parking garage fire is through the road in and out of the garage. That might not be the best way in, because it means you have to go a long way in the smoke to reach the fire. And in the pre-plan, if you look at the emergency exits for the parking garage, that could be the best way in. And to be able to reach the fires sooner, to have that in the pre-plans is excellent. Also, for parking garage fires, if you could enter with the positive pressure ventilation from the door where you enter, and you let the smoke out where the cars go in and out of the garage, I think that's an advantage. That means you have to place your fire vehicles in a wise spot, so you don't have them parked where the entrance to the garage is. Also try to figure out, is there fire ventilation in this garage? Is there sprinkler systems? All this could be addressed in a pre-plan. And if you combine that with when you choose a way of dealing with the fire in this specific garage, if it's high expansion foam, if it's a special garage pack, or if it's a sprinkler system, to have that in the pre-plan is great. We have been talking a bit about putting water on the outside of the battery casing, and I would just like to compare that to fighting an attic fire at a building. We don't put it out by putting water on the roof. We put it out by getting the water into the fire, and I think we could think about the same way with this battery casings. We need to get the water inside the battery casing. In this project, together with the Uppsala Fire and Rescue Brigade, we try to make some equipment to inspire, because we don't have the answers. We are just in the beginning of this, and this is just my thoughts about what we could do, and we wanted to show some kind of equipment that could inspire about how to do this. And this first one we're looking at, those are small pipes with quick connections, couplings between the pipes, and where we have nozzles on each of those pipes. And the goal here is basically to put the water above the burning car. The middle nozzle is to put the water above the burning car to protect the building. The other two nozzles are to put water on the adjacent vehicles to protect those vehicles. So we don't use any water here to protect or to put out the battery fire. It's all to contain the fire to the already burning vehicle. And this was very easy to use. You could connect it, pre-connect it before you enter the garage, and just put it out and direct the nozzles in the right way. The other thing we tested was a garage pack, where we used hoses with pre-connected hoses. So there is only one connection that we needed to make. And the other hoses were supposed to roll out in a smart way when we put pressure on the system. And it was more complicated than the pipes that we saw earlier. But it was more flexible. If we have two fires burning, we can move one of the nozzles in an easy way. So we can reach more vehicles. In both of those, both this one and in the previous one, we have 70 liters per minute per nozzle, which is 200 liters basically per minute in total. And in Sweden, we have about 3,000 liters of water in the fire engines. So we have about 15 minutes before we need to have a hydrant systems connected and get more. So, and that also means that we have quite a little bit of water compared to what you could use if you were going to flood this vehicle. This thing here is a German extinguisher for battery casings, and it's really clever. It's a piercing nozzle that you can get in through the car sheet metal, and it was very easy. And 2 men to get it in through the sheet metal was pretty easy, and it was heavy, but still easy to work with. They will be using this, as I understand it, on the Volkswagen workshops together with the F500 extinguishing agent. And if we talk about the hazards with this method of piercing something into a battery, that would maybe concern you that we will get a thermal runaway even more, because we are mechanically piercing the battery cells, and that will probably cause even more thermal runaway. But what we do get at the same time is extinguishing agent into the battery casing, and that will prevent this thermal runaway from spreading to more cells than it was already involved. So I think this could work. There is also the danger of electricity that we would need to address. In this case, we need to consider that the battery habit electricity, there is a plus and a minus, is all within the battery. So the short circuiting that will appear happens within the battery. There is no grounding in those systems that makes it dangerous for the firefighters holding it, which I also think is an important thing to know. Okay, if you have seen this much on the video, I thank you very much for your patience, and I'm sorry for my not always perfect English, but I hope this has been an inspiration. That's what I would like it to be. We don't have all the answers yet. We need to teach each other. If you have any methods or anything that you would like to share with me, the email address is here. Please email me and let me know what you think about it. If you think something is wrong with it, because I'm glad to admit if I'm wrong, and we'll learn from that. What I've talked about is from the different research reports, and I hope and I think that right now in time this is what we know, and hope you enjoyed it. Thank you very much.